Welcome back to section 7 of chapter 1. In this one we're going to be looking at function notation. We just looked to see what functions are. Now how do we write them? So, our learning targets for today. I can write functions using function notation. And I can evaluate and graph functions. We're going to be focused on evaluating. Graphing at this point, you literally just find some points, graph the points, and then connect the dots. There's not much to it. We're going to be focused a lot more on graphing throughout each of the chapters. We'll be graphing lines next chapter, and then quadratics in chapter 5, and beyond that, focusing on specific things. So, function notation. What is function notation? Function notation is a notation where we use things like f of x. It does not have to be f and x. It could be g of x. It could be h of t. But this is pronounced f of x. This is not f times x. X is the argument here. It's not multiplied. And what f of x means is basically just means y. It's the y value at that given x value. And so we use this for several different reasons. One, it allows us to have multiple functions at the same graph, and they can be named different things. We could have f of x, g of x, h of x. Another reason is we can change our variables to actually give them meaning. We could have like h of t, that could be height at time t. And the other reason why we use it is because it pairs the x and the y values together into an ordered pair. And that's something that gets to be important, and we'll see that as we're evaluating. So, an example, we could have an equation, y equals 6x minus 2. Well, instead of y equals, we just make that f of x equals 6x minus 2. So whatever equation you're going to write with y equals, to write it in function notation, you just use f of x equals. This variable is the same as this variable. That's important. And so, if we're going to be evaluating functions, let's say we're going to evaluate for f of 0, f of 1/2, and f of negative 2. All of this means is that we're going to replace the x, and we're going to plug in this number. So let's use the same equation that we have, f of x equals 6x minus 2. For f of 0, we're just going to replace all the x's with 0. And then simplify. 6 times 0 is 0 minus 2. F of 0 equals negative 2. Notice there's an equal sign still here. It's not just negative 2. F of 0 equals negative 2. That says when x equals 0, y equals negative 2. It ties the two together. If we just had y equals 6x minus 2, right, find for when x equals 0, 1/2, and negative 2, we'd end up with like y equals 0, y equals something, and y equals something else. Well, those have to be tied to the x values because that is something that's important. So that was for f of 0. Do the same thing for f of 1/2. We're just going to take out the x and put in 1/2. So f of 1/2 is 6 times 1/2 minus 2. 6 times 1/2 is 3, minus 2 is 1. So f of 1/2 equals 1. And same thing again for negative 2. F of negative 2 equals 6 times negative 2 minus 2. 6 times negative 2 is negative 12 minus 2 is negative 14. So f of negative 2 equals negative 14. So notice these three things. It's just three separate little problems. Don't try to do them all at once. And your answer should be f of something equals something. There should be an equal sign in that answer. So that's if we have an equation. What if we're going to evaluate, here we have f of 0, f of 1.5, and f of negative 4, and we're going to evaluate from a graph. Now this throws a lot of people off, and I've yet to really figure out why. Because this is actually easy, you don't have to do math. So f of 0, this says when x equals 0, what is y? Well, when x equals 0, y is up here at 3. So f of 0 equals 3. That's as easy as that is. How about f of 1.5? Well, when we go over to 1.5, we get up to 4. So f of 1.5 equals 4. And f of negative 4, we go back to when x equals negative 4, and that equals 4 again. So f of negative 4 equals 4. Now, a quick review from yesterday. Is this a function? Yes, because it passes a vertical line test. It doesn't matter that these two both equal 4. For each x value, you get exactly one y value. So that is really all there is to this section. Graphing, just find a couple points, plug those in, and then connect the dots. And writing functions, it's up here. You write them just like any equation. In a word problem, the word is gives you where your equal sign is. And that's it. See you again for section 8.